Financial maths. So in this section, we're going to be looking at values of money. So how does the economy affect the value of what money is worth now in the present or also in the future? And to do that, we're going to be using a formula which will basically underlie the whole chapter. This formula is going to be found on page 30 in our maths tables. And you can see it's the very first one there, which is F is equal to P times 1 plus I to the power of T. And this is going to be used in 3 different ways. So rearranging it to look for future values, which is what F is going to represent. P, present value. T will represent time. And I is going to represent interest. And you'll see there, it's important to note on page 30 that it tells you that T is the time in years, but not always will it be in terms of years. Hence we have this little star here. So the star is down here in the bottom. And T is going to basically, I prefer to say, represent our compounding period. So that time can be years, it can be months, it can be biannually, and it can be quarterly. I is also another one to note, is the annual rate of interest. But again, this is starred because it doesn't always have to be the annual rate. It'll be the rate by comparison to the time. So if our time is going to be in years, then we'll want to use our annual rate. If our time is monthly, then we'll have to change our rate so that it matches and corresponds to monthly. But that will always be written as a decimal or as a fraction and not in terms of percentage. So if it was 8%, we would write that as 0.08. So we write it as a decimal always. So obviously stock markets and, the current economy will affect the rate of these interest values. So they're always going to be given to us in the question, or else we're going to have to try and find that out. So why do we want to use this formula? Well, it's all to do with businesses and economics. So we're going to be looking really at money coming in and out of a company, or banks giving loans, or mortgages, or pensions. All looking at what will a value of money be in a few years' time, or if we're given the money in the future, what is it worth in the current present day? So we'll look at compound interest, we'll look at present values, we'll look at depreciation, we'll look at mortgages, we'll look at bonds, and we'll look at pensions all the way through this chapter. But it'll always come back to this one formula. F is equal to P times 1 plus I to the power of T. And depending on which letter we're looking for, we'll be rearranging that. Depreciation is the only one that'll be slightly different because it'll be negative, and we'll come to that during the week. So today we're going to start with cash flows. So the first thing we want to look at here is calculating our present value. So here in this example, we're asked to compute the present value of a future payment of $58,564 in 4 years' time, given a discount rate of 10% per annum. So in other words, if our value in the future is 58,564, how much will it be in the present day if we're discounting back 4 years, given that the interest rate is 10% per annum? So per annum means per year. So of course, as I said at the start there, we have to write our interest rate in terms of a decimal. So 10% as a decimal is 0.1. So our formula in our maths tables we saw there was on page 30. And because we're looking for present value, well, we're rearranging our equation so that it's written as P is equal to F over 1 plus I to the power of T. So to find the present value of 58,564, all we need to do is work out what is it if we discount it back 4 years. So we sub in for F, sub in for I, and sub in for T. So if we put that into our calculator, what we end up with then is 40,000 exactly. So what this means is that if we had €40,000, we were getting 10% per annum, then in 4 years' time, that would be worth €58,564. Okay, so type 2 then is looking at net present value. Where we will have more than one value coming in and out of account. So if we're looking at net present value, essentially what we're looking at is the present value of all cash inflows minus the present value of all cash outflows. So this would be important if you're looking at investing in a company and you want to know, well, are they worth the investment? So in other words, if their net present value is greater than 0, then we say the investment is going to yield a profit. So this would be a good investment. So you'd want to be really looking at a company over several years, not just 1 or 2 years. And then if the net present value is less than or equal to 0, then we say it's either going to break even if it's equal to 0, and therefore it's not making a profit or a loss, but it wouldn't really be a good investment. And if it's less than 0, then we say the investment will make a loss. And therefore it would be a bad investment. And obviously there's a lot of factors to consider when investing in a company, not just looking at their cash flow. But in these particular questions, that's all you're going to be basing your judgment on. So if we look at our example on page 248, question 7, we have sources presented with the following investment projects, and all the amounts are in euros. So we have project A and we have project B, and we have to basically advise Sourcia which project is more profitable if a discount rate of 6% is used. In other words, we have to compare the net present values. So we have project A has year 0, so they have minus €10,000. In other words, they've had to input €10,000 into the company. And in year 1, they've also had to input another €3,000. So in other words, there's cash outflow. And then in year 2, we have an inflow, so we have a positive value, so 4,000, and in year 3, 6,000, and in year 4, 8,000. And then in project B, the people have had to input 5,000 into their company in year 0, and in year 1, 2,000. So in other words, our outflows are 5,000 and 2,000, and our inflows in year 2, 3, and 4 are 1,000, 3,000, and 7,000. So in order to compare these companies fairly, what we're going to do is we're going to work out the present value for each year, in other words, for each value. So 0 wouldn't have to be discounted back, 1 would have to be discounted back 1 year, 2 would have to be discounted back 2 years, 3 years, and then 4 years. And once we get the present values of each of those amounts, we can then sum them up to get the total for project A and the total for project B. In other words, work out the net present value for project A and the net present value for project B, so we can compare them fairly and see which has the greater net present value. Okay, so let's look at project A. And I'm going to make a table out. So I'm going to say year. And then we're going to have the outflow or inflow. And then we're going to have our interest rate, and then we're going to have the present value. So for year 0 for project A, we have 10,000 going out. Our interest rate, we're told to take is 6%. And of course, we have to remember that 6% is going to be written as 0.06. And because we're looking at the present value and it's year 0, well then obviously that is going to be 10,000. And our present value we're taking is in euros. So I'm going to put my unit at the top there. For year 1, we have minus 3,000. So at an interest rate of 0.06, well, we're going to have to discount that back. So that's going to be minus 3,000 divided by 1 plus 0.06 to the power of 1. And therefore that's going to be minus 2,830.19. In year 2, we have 4,000 coming in at 0.06. So I'm going to discount 4,000 euro back 2 years. So 1 plus 0.06 at this point, I'm just going to write 1.06 to the power of 2. And then that works out to be 3,559.99. Year 3, we have 6,000. We're going to discount that back 3 years. So if we discount that back 3 years, that's 5,037 euro and 72 cent. And then year 4, we have 8,000 coming in, and we're discounting it back 4 years. And therefore that is a value of 6,336.75. Okay, so now we have the present value of each of our amounts, our inflows and our outflows. The next thing we want to do then is work out our net present value. So to get the net present value, what we're going to do is we're going to get the sum of all of these present values, making sure we're using our pluses or our minuses. So our outflows are negative and our inflows are positive. So by summing those all up, we end up with 2,104 euro and 27 cents. And this net present value is greater than 0, so it would be a good investment. So let's compare it then to Project B. So for Project B, in year 0, we had 5,000 going out. It's still the same interest rate, so it's still 0.06. And therefore in the present value in year 0, it's just going to stay as 5,000. So we don't have to do anything to that one. In year 1, we have 2,000 going out, 0.06. Therefore I have to discount that back 1 year. So that's 2,000, 1.06 to the power of 1. And therefore that gives me a value of minus 1,886 euro and 79 cent. In year 2, we have 1,000 coming in. And if I discount that back 2 years, then we end up with minus, or plus I should say, sorry, which is 889.99644. So I'm just going to round that to 2 decimal places, which brings that then to 890, if I'm keeping them all correct to 2 decimal places. And then we have 3,000, which again needs to be discounted back 3 years. And that gives me 2,518 and 86 cent. And then the last one is 7,000, and this has to be discounted back 4 years. And that gives me 5,544 euro and 66 cents. So again, if we work out our net present value by summing them all together, we end up with 2,066 euro and 73 cent. So again, this is also a profit because our net present value is greater than 0. So both are profitable, but we need to see which one is better. And obviously Project A is going to bring in more money, so it would be the best one to invest. So we would conclude then by saying, so So we'd say both project A and project B are profitable, but A is more profitable and would therefore be the best one to invest in. Okay, so let's go to our books then, and we're going to go to page 247. And we're going to do question 2, 3, and 4. And then I'll get you to do question 9.